Hello, can you hear me? I think your microphone is off.
Apologies for that.
Thank you, it's okay.
Yeah. Right, try again. Okay, so what we're talking about is unidimensional data using the example of conventional altimeter. And the problem with this is that because it's easy to misread under stress, it led to many crashes. Now, airplanes falling out of the sky because they misread where they are is not a good one. So there's the explanation of the three things. And the crashes were happening with experienced people, properly trained or qualified and everything else. But it's that misreading under stress that was the problem. So conventional altimeters have largely gone out, and we have digital displays, and that's rather easier. Okay, so if you have something that is, oh yes, your altitude is 3,210 feet, that's fine. Okay, that's a real number. If again, you can have a visualization of that, not quite as easy to read, but again, whichever way we look at it, they are easier to read, and more importantly, we have control over what's displayed. So rather than there being a sort of basically electromechanical thing behind there with some quite severe limitations, because we have a screen, we have software, we have a lot more things that we can do. Okay, so our next instance of unidimensional data is box plot. So here we have a very small little data set about snow depth. Okay, snow depth ranging from 50 centimeters to 250 centimeters. And if we wanted to represent that as a box plot, what we would do, okay, so there's the scatter plot on the top, and on the bottom we have the box plot, and what's that showing us? So we have got the minimum, the maximum, that's fine. We've got the lower quartile, the upper quartile, so that's so if you look, you count, you say, yes, there's three values above that, which is a quarter of the 12 values there, and so you can see the distance in which the middle half of the data is, and then we have the median. So this is the point where half the values are above and half are below. Now, if you thought, and the median in this case is actually a better indication because it is closer to the vast majority of readings. Okay, so if we think about it, we've got most of our readings in that, what we said, 70 to 120 depth, and then we've got some a couple in the middle, and then some big high depths up here. So we've got a group up here, most things are down here, and there's very little in the middle. And this actually is capturing that. Okay, so it's saying half, so there's a quarter in there, there's half in there, and you've got a much bigger range. And again, so you've got a quarter in there. So you can see, I think, more of the pattern from the box plot than you would from the straightforward descriptive statistics as numbers. Okay, so there we are. We can represent it as a histogram, shows us the same sort of thing. Again, it's very easy to see the pattern. Now, what we've done is, we put these together. We said, okay, from 51 to 100, 101 to 150, and so on. Now, it shows the same sort of pattern, but perhaps not in as much detail and quite as usefully as with the box plot. Okay, again, it depends what we're looking at, because the box plot, to be useful, you have to have people who are more familiar with it, who know how to interpret it. Whereas if you put the histogram up, pretty much everybody can look at one and think, oh yes, I understand what's going on there. Okay, we can also use bargrams, same sort of idea. And again, a bargram, if you wanted to convey that information to a large number of people, might be a good way of doing it. Okay, so who are you trying to communicate with? What are the messages you're trying to get across? Okay. So that's better, isn't it? Sorry, my Mac just said it was on a low battery. Yeah, it should be all right. Okay, that's gone away. Good. It wasn't quite plugged in correctly. So bidimensional data. Right. We have here a table. Now you can see here is a table of all the exact values. It's fine. Trying to make sense of it, not so easy. But this is very famous data. It's Anscombe's quartet. And Anscombe's quartet, all those data sets have mean X of 9, mean Y 7.5, sample variance of X11, of Y 4.12, correlation 8.16 between the two, a linear regression of 3 plus 0.5x. Great, okay, so we have a very nice coherent set of data. We think we have four data sets, all with the same values. We plot them. Okay, we plot that data, and this is what we get. Those data sets, although the statistics are identical, they are actually very different data sets. So, big visualization message, never don't do the graph. Never rely on the numbers without doing the graphs, because the graphs show you stuff that if you looked at the numbers for long enough, you'd probably pick it up, but most people wouldn't. You think, oh yes, the statistics look fine, done, off we go. Very different things. Okay, so the message: identical descriptive statistics may conceal very different underlying patterns. And okay, Anscombe, when he did that work in 1973, this is, oh look, here is this example, but since then clever people have sorted out and generalized it, and the references at the end of the slides. Message: no substitute for looking critically at the data. So you think, oh yes, the statistics are telling me this is all the same. Let's have a look. Okay, let's have a look. No, they're not the same. Right. Okay, so we mentioned briefly a scatter plot, and scatter plots, when there aren't that many data points, are very good. If there are too many data points in, your scatter plot just either turns into a sort of mass of blobs, or you get so many overlying each other that you can't really see what's going on. Where you've not got that many, they can be really quite nice. So here is a plot here. Economists, you're allowed to wake up at this stage. And so, oh look, this is the OECD countries, so the richer countries in the world, GDP per capita from 2012. Okay, so what this plot has got is what is the per capita income and which rank are they. So okay, so it's rank order, and what we can see, very nice, it's very easy to see a pattern. Okay, most countries, there is a fairly straightforward relationship between rank order and ranking the list and income. Declines very nice and steadily. Okay, and then you've got these 4 outliers up here, and if I remember correctly, it's something like United States and 3 little tax havens. Somebody will tell me I'm wrong in a minute, but it's something like that. But you look at that data and think, okay, there's a fairly steady trend, and then you've got these four at the top. What's going on with them? Why are they so different? Okay. Here we have, again, a fairly old example, the time series of the growth in the numbers of internet hosts. Okay, so this is starting way back when you've got very, very few, and then suddenly, okay, here we go, we're into the mid-90s, and if you like, this is the prehistory of the internet, and then in the mid-90s, things start shooting up, and oh look, it's pretty much an exponential growth, and there's a blip there, and we look at that and think, I wonder what happened there, and it goes on, and we don't really get much later data because it gets way too difficult to actually count. Okay, now what we've done is said we'll plot this as a single line per series. Okay, so where we've got time series, we're thinking it's a continuous measure, so hence the line is appropriate, and if we've got time in it, time is always on the x-axis. Always, always, always. Okay. Okay. If you saw something with a time on the y-axis, you'd actually, even if it was accurate, you'd spend the first few minutes puzzling out why is time on the y-axis? What's it doing? Why has it gone wrong? And when you're doing that, you're actually not looking at the visualization. You're thinking, why did they do it like that? So any communication has suddenly got lost. Okay, so if we've got discrete events, we can also use time series. So here we've got executive orders made by presidents of the United States looking, okay, this is from a year ago, looking at, okay, the last four, so George Bush, Barack Obama, Donald Trump, and Joe Biden. You can see he'd only been in office for a few days, but he'd done an awful lot of executive orders, and I think a lot of those were undoing things that were done here. But anyway, so you can see how the last three presidents of the United States have made much greater use of executive orders than their predecessors, who are in that sort of pale blue background. So again, what you're seeing here is a timeline, days in office at the bottom, as you'd expect, numbers of orders. Now, slightly unusual to see the y-axis on this side, but it works perfectly fine because, again, I think if we put it over on the left, then actually the y-axis would interfere with seeing this big Joe Biden thing. So again, if I can imagine whoever designed this would have started out with the y-axis in the normal place, thought, you know what, that's not working terribly well because we're not seeing Joe Biden very clearly because Joe Biden is getting bundled up with the axis. Move the axis across to the other side, the labels, and suddenly it works a lot better. Okay, so all sorts of things, and again, note the use of color. So the four are colored in shades of red and blue, the party colors for Republicans and Democrats. Okay, so three-dimensional data. Here we have a three-dimensional scatter plot. Okay, this is so you can do them, and you will notice this is a high chance chart. That's fine, and you can rotate it and you can do all sorts of things with it. Click and drag the plot. So high chance gives you this sort of facility, and you may not have noticed yet because we haven't talked about it, but actually, if you any high chance chart, if you want it as a PDF or other static formats, there is a facility with this hamburger menu. And again, there's an option to display or not display the hamburger menu. we can have a look. Okay, so here's a 3D surface chart, and what this is a chart is trying to convey quite a lot of information in one chart. So it's looking at information retrieval, so it's retrieval based on visual features, and it's showing, well, how many features do we take into account, how much detail in each of the things we're looking at, how many nearest neighbours do we take into account, and then let's make it rather more comprehensible by using colour. Okay, so again, it's categorical colour because these are precision and recall values, which you can see down here. But the colour is making it easier to understand and see what's going on with this. Okay. We've seen spectrogram before, but again, I put it up again as a reminder that we're using colour and colour intensity. We've got time along the bottom, and we've got the sound frequency. So we can see lots of little and lots. So that we've got a lot of encoding going on there. We've seen bubble charts from Hans Rosling. So if you want another 4.5 minutes of Hans Rosling Gapminder, there's a nice link. Okay, and again, this is looking at bubble charts and bearing in mind what we said last week about perception. Yes, we know that we will perceive the larger bubbles as not quite as big as they are in reality, but from what we've seen before, having looked at this stuff without having looked at the representation issues, then we know that we're picking up what's big, what's not big. Okay, so enough of the key messages are getting across that we can understand all the important things are coming through very well. And we run the thing and it works nicely. Okay, other things we can do, hyperdimensional data. So one of the nice charts we've not looked at yet, but we will look at today, a good one for the lab, is the windrows. Okay, we've seen something similar with Florence Nightingale and the casualties in the Crimea. And what we have here in the windrows is something which says, right, where does the wind come from? How many days a year does it come from various directions? And how strong is it? Okay, so direction, frequency, and speed, all in one chart. All right, okay, so speed in meters per second, and there we are. Right, so these are very useful for weather, and they are, if you're thinking about building a new airport or airstrip, then they're the first thing you look at. Where does the wind come from? Because what you always want to do is to align the runways or airstrips with the direction of the prevailing wind. So you take off and land into the prevailing wind, which is better. Okay, so we can have a variant of that, the star plot. Star plot, beloved of the education world, and we've got categorical stuff. And the idea is that we have individual performances on these various measures, and we build a set of individual polygons, and quite often we put the mean in there as well. The education community loves them. I say no more. Here we have something similar used for group comparisons. And again, this is getting to be a visualization where if you want to do the comparisons quickly, you really need some expertise. So this is looking at drug trial results, so item scores by treatment group. So we've got 2 treatment groups, and what are the things we're looking at? Depressed mood, feelings of guilt, suicide, and so we can look. We've got the detail around the edge. Now, if you're regularly looking at this sort of stuff, you get to understand. I'm out. There's a lot of information here. It's not hugely obvious. It will take people without a pharmaceutical background quite a long time to make sense of these things, but you can. Okay, and but you can see what the major differences are. You can see, that spike is much less there. That bit there is much truncated compared with that. No real change over here, and so on. Another very widespread and informative sort of chart is population structure. And what the population charts have, again, they're always the same. They have males on the left, females on the right, and they're grouped into age bands. And okay, so you work from 0 outwards, the 0's in the middle, and so what you see is the number of 0 to 4-year-olds, males and females, and so it goes on. And what you expect is, again, you can see the sorts of patterns, the sorts of curve that you get for various countries. So if we look, so this is from 2014, Germany, what we can see is, again, that you can put the numbers in various places. But in 2014, we can see this big boom, large numbers of people who were in 2014 in the sort of late 40s through to late 50s, and then you've got a really quite steep decline after that in the older population, and then steady declines in the numbers of younger people. Okay, so that's interesting. And again, if you looked at, go back 50 years from 2014, and you're in that immediate post-war period, so you've got that. That's when you're looking at that post-war, post-Second World War economic recovery, and you can see that population bulge moving through. If you look at Russia, not that far away, you've got a very different sort of structure. So what's going on here? So again, it's right. I think the most obvious, one of the most obvious things is that in Russia, you've got a huge discrepancy between numbers of men and women in the older age groups. Okay, now we identified here that this group, this was about the end of the Second World War, so this is actually sort of Second World War generation, people who were alive during that period. And you can see there's a huge disparity in the number of men and women, and there's not many of them. So when you say, oh yes, the Russians had a lot of casualties in the Second World War, and you look at that, you think, yep, and we can see it. We can visualize that in terms of the population structure. And again, to me, it's this, the male-female skew is a very interesting one. Right, and again, India, okay, we can see a very different shape. Very different shape indeed. Huge numbers of younger people, and again, what we see this, so 5, okay, so we can see an excess of boys over girls for whatever reasons. Okay, so population structure charts, standardized, but you can see that they tell you an awful lot about what's going on. Okay, Next thing we'll look at, final thing here, we'll look at mosaics. Okay, so here we've got each individual here is represented by a small square, and the squares can be divided in colour to show different categories. So here's a reasonably complex table of survivors from the sinking of the Titanic. Okay, so it shows how many people, male and female, adult and child, survived, yes or no, from whether they were first, second, or third class or crew. Okay, so you'd be glad to see that there were no children in the crew. That's always a good start. So what do we do? Okay, so we take the total number, we divide them up by what class they're in, then we divide them up between whether they were male or female, and then whether they survived or not, or didn't survive. Okay, so we end up with something that looks like that. Again, for certain things, it can be very useful to illustrate what's going on. So, oh look, here, what we see is first and second class children seem to do pretty well. Third class children didn't. And you can do all sorts of other things there. Okay. So, a couple of references, Anscombe and the generalization of Anscombe, and a final mosaic chart in two forms. I said at the beginning that it was rare for us to talk about things which had a significant artistic component. Here is one of the exceptions. Okay, so each pixel in these images represents one casualty in the Iraq War. Okay, and you can see, right, so these are the totals. Okay, so with a legend, and here is the distribution through time. Okay. And I first saw this image about 6 years ago now. No, 5, in an exhibition, and was really quite struck by it because it's quite a big. You see something about two things about 1 meter across, stuck on a wall. You think, oh, yes, okay, right, okay. So that's all I want to see about representation. Good. What I would like to do then is say a little bit about accessibility and visualization. Okay, so we have been talking, slideshow. No. Okay, so this is a little bit about accessibility and visualization, because we have been talking about seeing things and looking at things. We have to remember that not everybody can see very well. So what can we do about it? First of all, we start from the principles of accessibility. Okay, so those of you who've done anything on human-computer interaction will have seen some of this before, so I'll talk about it quite quickly. But so, for a resource to be most accessible, it must be able to be used by a person with a disability for the same purpose, the same effectiveness, and with a similar amount of time and effort as somebody who is non-disabled. It's expressed as a set of guidelines. Things are getting easier for us because modern operating systems and operating system APIs do make it easier to build accessible apps. So the key thing here is the WCAG guidelines. Now, Web Content Accessibility Guidelines, so this is a working group of the World Wide Web Commission, and essentially it's a bunch of pretty motivated and clever people sat down and came to a big consensus about what was important. Now you might be thinking, oh yeah, okay, yeah, this is all a bit peripheral. The key thing we have to bear in mind for visualization is that if our work is not accessible to people, and we haven't taken reasonable steps to make sure it is accessible, then you can reckon that in most regions of the world, we will fall foul of equalities and disability legislation. And in a commercial environment, it's not great to be pulled up for discriminating indirectly against disabled people. It doesn't look good and it costs money. So it's something that we need to take account of. And if we take account of it by saying, okay, we can show that our work makes all reasonable efforts to stick to and adhere to accessibility principles, then we're in a pretty safe place. Okay, so principles: provide text alternatives, and this is probably the most important for us, provide text alternatives for any non-text content so that it can be changed into other forms people need, large print, braille, whatever. Alternatives to time-based media, so that's video and audio. Create content that can be presented in different ways without losing information or structure. Make it easier for users to see or hear content, including separating foreground from background. So a lot of these things are things that are good for everybody, but are particularly critical for people with various sorts of disability. Okay, all functionality available from a keyboard. Give people time enough to read and use content. So if you've got something that displays on screen only for a limited amount of time, it needs to be there long enough, or people need to be able to hold it there, or better, to only move away when they are ready to do so. Don't design content in a way that's known to cause seizures. So this is about flashing, provoking epileptic fits, and similar things. Provide ways to help users navigate, find content, and determine where they are. Make text content readable and understandable. So when we write stuff, can ordinary people understand what's going on? Make web pages appear and operate in predictable ways. Help users avoid and correct mistakes. Maximize compatibility with various technologies. So of those, it is the first one that is of real concern to us for visualization. The others are all really important, but I won't say anything more than here. But just bear in mind that first one. Okay, so most operating systems have now got screen readers, spoken content, transcription, captions, and so on, voice control, variable sensibility controls, and so on. They're good. That's fine. Not everything's perfect, but we're in a lot better position than we were 3-5 years ago. We need to think about mobiles, and again, we have to think how do our visualizations work on mobile devices? What do we need to change to make sure that they work, and so on? Okay, there are all sorts of open issues here. We won't talk about those anymore, but now this is relevant to us. So we are going to end up with screens which people are going to read. Now, for most of us, we would say they're usually read from top to bottom and left to right. Obviously, if you're using a language which is written right to left, then that order is reversed. Okay, so it's important to make information available early in the sequence. So if it's important, get it there early. You saw a heat map last week. Again, where do people's gaze function? Where's their focus? Right, now, if we have, the worst thing we can do is to say, oh look, we've got a visualization, we'll take an image of it, JPEG or PNG, and we'll paste it into our page. the only thing you can do that is look at it. Ouch. Okay, so we know that we can do hugely better than that. And high charts provides some quite nice facilities to help us. So how do we go for accessibility visualizations? If we look, here's a caption, okay? Now, I'm going to turn around because the text is very small. So Pareto optimal portfolios obtained by deterministic optimization. The principal axes show the capital cost, supply deficit and reliability objectives. The eco-deficit objective is depicted by the color scale. The red solutions illustrate the highest eco-deficit, while the blue solutions show the lowest eco-deficit. The orientation of the cones illustrates the resilience of the portfolios and the size of the cones, the energy cost requirements. Cones pointing upwards indicate worst resilience, while cones pointing downward, the best resilience. The bigger the cone, the higher the energy use portfolio requires. The arrows point towards the direction of preference, i.e. the ideal point would lie in the lower central corner of the cube and its cone would be of the smallest size. Blue colour and pointing directly downwards. Given the inherent trade-offs between the objectives, such performance cannot be achieved. For interpretation of the references to colour in this figure legend, the reader is referred to the web version of this article. Now, that has given a long and detailed description of the visualization, and we are no wiser. So what does it actually look like? Okay, so that was a long, low-level description, not helpful. You are quite entitled to say, and the visualization itself isn't very helpful either. We look at this and we think, oh, what does it mean? That we leave for another day. But the point about long, low-level descriptions not being useful is the point to bear in mind. So what can we do to help things? For a start, if we, again, it is a standards requirement. When we have an image, we are expected, we have to provide some sort of short descriptive text. Okay, so it might be a UEA logo or something, or it might be image of person in swimming pool looking at computer looking surprised. So all sorts of things like that. Okay, so if we want to do something a little better than that, we have that alt text, that short descriptive text, and we wrap it in an anchor tag, which is a link to some long descriptive text. Okay, again, all sorts of things we can do, we just need to be thinking about them. Right, so how do we do useful text descriptions for our visualizations? There is some nice recent work which I'm going to summarize here in the next few minutes. So this is Lundgaard and Safrayan from earlier on this year. So captions for blind readers should aim to convey a chart's trends and statistics rather than solely detailing its low-level design elements or high-level insights. So they're saying we've got a hierarchy of things we can describe and we want to be somewhere in the middle. Right, now, we have differences between readers, and they're quite big differences, and those differences, as far as we can see at the moment, depend on data literacy, domain expertise, and visual perceptual ability. So we know that there's not a one-size-fits-all. Whatever we do isn't going to work equally well for everybody. But what we can do is do something that should work reasonably well for the majority of people. So they have helpfully characterized things as into 4 levels. So elemental encoded level, that's the chart type, so the stuff that I just talked about with that long and confusing description. So you can see that is not very helpful to us. Statistical and relational stuff, this is our descriptive statistics, extreme values, outliers, and so on. Okay. Perceptual and cognitive, so things about complex trends, pattern synthesis, so on. And then the contextual and domain specific at the top. So domain specific insights, current events. So in other words, giving context. If you think when I was talking about the population charts, I was illustrating why they might be useful and how we can interpret them by reference to external events. Okay, so that, if you like, that is my interpretation, my gloss on what those charts are. When I was talking about, oh look, you can see this big boom in the numbers of people being born in the late 40s, early 50s, and you can see this huge diminution, and you can see, so that's talking at the perceptual and cognitive level, and dropping down to the statistical. Okay, so we have these nice 4 levels. Okay, and if we look at this, I'm not going to read the whole thing, but essentially what is happening here, right? So this is looking at life expectancy by gender and income, and the takeaway message is that so the coding's the same. So this is a scatter plot. It's right. So the sort of low-level stuff we saw before, which actually we know is not very helpful. The most helpful things would be for low-income countries, the average life expectancy is 60 years for men and 65 years for women. For high-income countries, the average life expectancy is 77 years for men and 82 years for women. Okay, so those are all things we can read off, because with high income, low income, we can see what the averages are. Okay, now that sort of level of description is the sort of stuff that is most generally useful. If we go on from there, we say people living in low-income countries tend to have a lower life expectancy due to many societal factors and so on. So you're putting the writer's explanation and understanding of what's going on there on top of the descriptive stuff. Okay, so it's this the semantic description is useful, not the so the low-level stuff, no. The mid-level stuff describing what the trends are, the interpretation, no. Okay, so that's right. In a nutshell, that's how to do it. Okay, and all right, how do they know this works? So they, again, you'd like to do more, you'd like to have larger samples, different ranges and so on, but it makes sense at quite a lot of levels. And I think I would say it is the current best practice would be to say, try for description at that level. Okay, so a variety of people, not as many as you'd like to repeat it and so on. Okay, but group levels 2 and 3 in the middle. Okay, there's the full paper. I will stop there, and we'll, given where we are on time, I'll leave the lab 3 background stuff and we'll talk about that in the lab. Okay, what I want to do next is I will stop the lecture recording.